of the presentation is to describe to you what is GPT. That's really difficult to explain in 15 minutes, and there are even a lot of things that we don't know, but a good way to approach that is to first consider all the things that people call GPT by, or descriptors. So you can call them large language models, you can call them universal approximators from computer science, you can say that it is a generative AI. We know that they are neural networks, we know that it is an artificial intelligence. To some, it's a simulator of culture. To others, it just predicts text. It's also a writing assistant. If you've ever used ChatGPT, you can plug in a bit of your essay, get some feedback. It's amazing for that. It's a content generator. People use it to do copywriting, Jasper.ai, pseudo-write, etc. It's an agent. So the really hot thing right now, if you might have seen it on Twitter, AutoGPT, Baby AGI, people are giving these things tools and letting them run a little bit free in the wild to interact with the world, computers, etc. We use them as chatbots, obviously, and the actual architecture is a transformer. So there's lots of ways to describe GPT. And any other one of them is a really perfectly adequate way to begin the conversation. But for our purposes, we can think of it as a large language model, and more specifically, a language model. And a language model is a model of language, if you allow me the tautology, but really what it does is it produces a probability distribution over some vocabulary. So let us imagine that we had the task of predicting the next word of the sequence I am. So if I give a neural network the words I am, what of all words in English is the next most likely word to follow? That, at its very core, is what GPT is trained to answer. And how it does it is it has a vocabulary of 50,000 words, and it knows, roughly, given the entire internet, which words are likely to follow other words of those 50,000 in some sequence, up to 2,000 words, up to 4,000, up to 8,000, and now up to 32,000 with GPT-4. So you give it a sequence, here I am, and over the vocabulary of 50,000 words, it gives you the likelihood of every single word that follows. So here it's I am, perhaps the word happy is fairly frequent, so we'll get that a high probability if we look at all words, all utterances of English. It might be I am sad, maybe that's a little bit less probable. I am school, that really should be at the end because I don't think anybody would ever say that. I am Bjork, that's a little bit, it's not very probable, but it's less probable than happy, sad, but there's still some probability attached to it. And when we say it's probable, that's literally a percentage. That's like happy follows I am maybe like 5% of the time. Sad follows I am maybe 2% of the time or whatever. So for every word that we give GPT, it tries to predict what the next word is across 50,000 words, and it gives every single one of those 50,000 words a number that reflects how probable it is. And the really magical thing that happens is you can generate new text. So if you give GPT, I am, and it predicts happy as being the most probable word over 50,000, you can then append it to I am. So now you say, I am happy, and you feed it into the model again. You sample another word, you feed it into the model again, and again, and again, and again. And there's lots of different ways that I am happy, I am sad can go. And you add a little bit of randomness, and all of a sudden you have a language model that can write essays, that can talk, and a whole lot of things, which is really unexpected and something that we didn't predict even 5 years ago. So this is all relevant. And if we move on, as we scale up the model and we give it more compute, in 2012, AlexNet came out, and we figured out we can give the model, we can run the model on GPUs. So we can speed up the process. We can give the model lots of information downloaded from the internet, and it learns more and more and more. And the probabilities that it gives you get better as it sees more examples of English on the internet. So we have to train the model to be really large, really wide, and we have to train it for a really long time. And as we do that, the model gets more and more better and expressive and capable, and it also gets a little bit intelligent, and for reasons we don't understand. So, but the issue is that because it learns to replicate the internet, it knows how to speak in a lot of different genres of text and a lot of different registers. If you begin the conversation like, ChatGPT, can you explain the moon landing to a 6-year-old in a few sentences? GPT-3, this is an example drawn from the InstructGPT paper from OpenAI. GPT-3 would have just been like, okay, so you're giving me an example, like explain the moon landing to a 6-year-old. I'm going to give you a whole bunch of similar things because those seem very likely to come in a sequence. It doesn't necessarily understand that it's being asked a question, it has to respond with an answer. GPT-3 did not have that apparatus, that interface for responding to questions. And the scientists at OpenAI came up with the solution, and that's, let's give it a whole bunch of examples of question and answers, such that we first train it on the internet, and then we train it with a whole bunch of questions and answers, such that it has the knowledge of the internet, but really knows that it has to be answering questions. And that is when ChatGPT was born, and that's when it gained 100 million users in 1 month. I think it beat TikTok's record at 20 million in 1 month. It was a huge thing. And for a lot of people, they went, oh, this thing is intelligent. I can ask it questions, it answers back, we can work together to come to a solution. And that's because it's still predicting words. It's still a language model, but it knows to predict words in the framework of a question and answer. So that's what a prompt is. That's what instruction tuning is. That's a key word. That's what RLHF is, if you've ever seen that acronym, reinforcement alignment with human feedback. And all of those combined means that the models that are coming out today, the types of language predictors that are coming out today, work to operate in a Q&A form. GPT-4 exclusively only has the aligned model available, and this is a really great, solid foundation to build on, because you can do all sorts of things. You can ask ChatGPT, can you do this for me? Can you do that for me? You might have seen that OpenAI has allowed plugin access to ChatGPT, so it can access Wolfram, it can search the web, it can do Instacart for you, it can look up recipes. Once the model knows that not only it has to predict language, but that it has to solve a problem, and the problem here being, give me a good answer to my question, it's suddenly able to interface with the world in a really solid way. And from there on, there's been all sorts of tools that build on this Q&A form that ChatGPT uses. You have AutoGPT, you have LangChain, you have React. There was a React paper where a lot of these come from, and turning the model into an agent with which to achieve any ambiguous goal is where the future is going. And this is all thanks to instruction tuning. And with that, I think I will hand it off to Ted